Hi everyone, this is question 2 in the 2019 test, part E. So I would advise you guys to all pause the video and try to solve this question first before I go over the answer. Okay, so I'm going to go over the answer now. What it's asking for is the density of wood over the density of styrofoam, okay? And we are given all this information about what floats and how much is submerged when it floats. If you guys remember, in generally the amount that's the percent that's submerged is equal to the density of the object divided by the density of the liquid. So in this case, like the object will be the wood, styrofoam, and plastic, and liquid will be water or oil. Okay, so what this means is, like, when the plastic block is placed in water, half the volume is submerged. What that means, if we write it in terms of this, that will be the density of let's see, the plastic. So density of plastic divided by the density of water is equal to 0.5, because 50% is submerged, half the volume is submerged. Now these cases are a bit more difficult, where we have both a wooden block and a plastic block on top, right? So like it will look like this. Oops. The water level is like this, and then it floats if the wood block is like this, and then the plastic block is like this. So all of the wooden block is submerged. Now I'm going to tell you right now, I'll prove it later, but this actually follows this formula as well, but in a different way. It's like since we're adding the two objects on top of each other, we're actually adding the densities together. So we have the density of wood plus the density of plastic over the density of water is equal to 1, right? Because the entire the entire wooden block is fully submerged. And I'll prove it right here. So basically in this two-block system, we know that the force diagram, the force of buoyancy going up has to match the force of gravity going down. Okay. So what is the force of gravity? The force of gravity is the mass of the wooden. Is it wooden? It's wooden and plastic. So the mass of the wooden block plus the mass of the what is it? Mass of the plastic block times g, and that's equal to the force of buoyancy. So the force of buoyancy is actually the weight of the water that's displaced, right? So how much water is displaced? Well, this entire volume that's underneath the water is being displaced, and we know this because it says all three cubical blocks are all made of the same volume. So if we just call each of the volumes V, then we can say that the amount of water displaced is V. So V water is displaced, is this much volume is water is displaced. So remember, M over V is equal to density. So if we're looking for the mass of water that's displaced, so let me say mass displaced times G, then all we have to do is plug it in. Mass displaced is equal to V times the density of water. And this should look like a familiar equation now. So this is V, density of water, times G. And these two G's can actually cancel out, so I'm just not going to write G here. And we can do the same argument with M over V is equal to the density with the mass of wood and mass of plastic. So if we say that the mass of wood divided by the volume of the wood, again, they're all the same volume, is equal to the density of wood. So we can plug in that the mass of wood is equal to volume times density of wood. I'm just going to write it out here. So this is going to be mass of wood times volume plus, and then same argument with plastic, sorry, this is not mass, this is density of wood, density of plastic times the volume. And now you can see that the volume cancels out all three places. So what we get is that the density of wood, right, plus the density of plastic divided by, I'm just dividing by water on both, the density of water on both sides, and that's equal to 1, okay? And it's equal to 1 because the entire volume is submerged. So now we just proved that this is the case here. Great. All right, and we can actually apply the exact same formulas. You can prove it for yourself. For this case, with the styrofoam block placed in oil and the plastic block on top, the styrofoam block is fully submerged. Okay, so let me write it out. We get that the density of styrofoam density of styrofoam plus the density of plastic divided by the density of water. This also equals 1. So these are 3 equations that we already came up with, and again we're looking for the final answer is the density of wood over the density of styrofoam. Actually, I made a little bit of a mistake. It says that the styrofoam block is placed in oil with the plastic block on top. The styrofoam block is just fully submerged. So this actually isn't water, this is oil. And one last detail they give us in the question is that density of oil is 0.7 times that of water. So how we write that is just density of oil is equal to 0.7 times density of water. Okay, so now we have these 4 equations, and now it's just a matter of substitutions and systems of equations to give us the final answer in terms of density of wood over the density of styrofoam. So we can begin by noticing that if we, just put this in, so right here we're given the density of wood, right here we're given the density of styrofoam, so why don't we focus on those 2 equations. This equation, I'm just going to put the density of water on the other side, so we have the density of wood plus the density of plastic is equal to the density of water. And then for this equation, we have the density of styrofoam, I'm supposed to put ST plus density of plastic, PL, is equal to the density of oil, but we know that density of oil is 0.7 times the density of water, so I'm just going to put that down here. Okay. And now we're also given that the density of plastic over the density of water is 0.5. So we actually can plug in the fact that right here, the density of plastic is equal to 0.5 times the density of water. And we can plug that into this plastic density and this plastic density. So that gives us the density of wood plus 0.5, the density of plastic is equal to the density of, sorry, this is the density of water. It's equal to the density of water. And then also plugging into the bottom one, so density of styrofoam plus the 0.5 density of water is equal to 0.7 density of water. So finally we can move this subtract 0.5 density of water from both sides, and then we can divide both these equations, so then we get that equation in the form of density of wood over the density of styrofoam, which is in our final answer. And that final answer is equal to 0.5 divided by 0.2, which is 2.5. And that should be answer choice A in the F = MA booklet.